We're here now. In a month, we'll reach the equinox point, the start of autumn. How does the moon affect the tides? Each month, the highest tides come when the Earth, Moon, and Sun are lined up. When there's a new moon, for example. At these times, the pull of the Moon and Sun work in the same direction, combining to produce the highest tides of the month. And the strongest tides of the year normally come with the equinox, because then the Earth's centrifugal forces are added to the pull of the Sun, raising the masses of water in the oceans. Yet there are years when the strongest tide doesn't happen at the equinox, but when there's a full moon in another month, August for instance. Why? Because of a factor we often forget, the distance of the moon. The moon's orbit is an ellipse. Sometimes the moon is farther away, sometimes it's closer. The closer it is, the stronger the tide. If the full moon in August coincides with the day when the moon is closest, this full moon brings us the highest tides of the year, even higher than the equinox tides. The great planet Jupiter, from year to year, it rises much later. Jupiter is the biggest planet in the solar system. It's surrounded by 2 very thin rings and 16 moons. With binoculars, you can see the 4 largest, the Galilean moons, discovered by Galileo. When Jupiter rises on the horizon, these 4 moons appear in a rising line. Then they slowly tip over into a falling line. That's because we're watching from Earth, which is turning. The Earth, the planets, and Jupiter, with its moons, all move on the same plane. Because the Earth turns, our viewpoint changes angle from hour to hour. The line formed by the 4 Galilean moons shows this even better. As the Earth moves forward on its orbit every evening at the same time, you'll see that Jupiter has moved 1 degree to the right. Every week, Jupiter slides 1 hand to the right, towards the west. And every evening, you can watch the ballet of the 4 Galilean moons. They revolve around Jupiter so quickly that every night they've changed position. And on certain nights, we can see Ganymede disappear behind Jupiter. As he watched these eclipses of Jupiter's moons in the 17th century, the Danish astronomer Olaus Romer discovered the speed of light. Romer observed the moons vanishing behind Jupiter. He watched as a moon approached and noted its disappearance to the minute. Several months later, he timed the same event. It came 8 minutes late. Several months after that, it was 8 minutes early. Baffled at first, Romer finally understood. When the Earth is farther away from Jupiter, light from Jupiter takes 8 minutes longer to reach us, and Europa seems to be behind schedule. A few months later, when the Earth is nearer, the light takes less time. The image of Jupiter and its moon arrives early. Romer discovered that light isn't instantaneous. It takes time to travel. With your binoculars, don't miss Jupiter's 4 great moons. Here they're spread out at their widest, except Io, which is very close to the planet. Io, Jupiter's closest moon, revolves around the planet in less than 2 days, while our moon takes 28 days to turn around the Earth. Io's the most colorful body in the solar system. Io is also the only place outside the Earth where we can see volcanic eruptions. We think it's sulfur blasted out by the volcanoes, which takes on different colors when it falls back down and cools on the surface of Io at a temperature of minus 140 degrees centigrade. The gas and dust thrown out by these volcanoes spread out in the moon's wake. Charged with electricity by the sun's rays, these particles modify the radio waves that Jupiter broadcasts into space. Sometimes, as you watch Jupiter's 4 great moons, you'll see only 3, because Io and Europa to the left of Jupiter cover each other. You can hardly tell them apart. With its 16 moons and its rings, Jupiter is like a miniature solar system. But its influence spreads much farther than that. 800 million kilometers to the right and left of Jupiter, 2 little asteroid clusters travel on its orbit, the Trojans. These 2 groups of asteroids float in space at very precise points, where the gravitational forces are in equilibrium. The Trojans form perfect triangles with the Sun and Jupiter, revolving around the Sun at the same speed as Jupiter, in 12 years, 12 times more slowly than the Earth. In your lifetime, this great bright planet will revolve around the Sun 6 or 7 times. When you see Jupiter shining in the sky, think about it.